Okay, so we started talking about electric fields and how those look. Let me just refresh your memory. Draw a picture. Here is my plus, and here is my minus. I'm going to call them the exact same. Remember, the electric field comes straight out of a positive charge. Out. And in my drawing, I'm going to pretend that they're both the same magnitude. So I'm going to have the same amount of field lines. And they go in to the negative. Okay. So this question says, I have this Q1 positive 2.5 charge. Oops, I have one of my magnitudes wrong. This should be -6. And a negative Q2 10 to the -6 charge over here. And I know that this distance separating them is 2.4. It wants to know, where are they zero? So remember, an electric field, the strength of that field is only dependent on the charge generating it. The force is the interaction between two charges. The electric field is one charge only. So if we want to think about where this is going to be zero, first thing we have to do is think about what our electric fields are actually doing. So this is coming out and this is going in this way. I don't know why I can't draw arrowheads. So this field is coming in. So the point in between these, I have a field going this way and another field going this way. So these can't be zero. These are summative. They're both in the same direction. So if we're going to add them, this is like two vectors on the x-axis, they wouldn't be zero. Over here, though, I have the vector coming in towards the charge, and this guy's vectors would be going, he would have at least one coming out. So now there is a chance for these two vectors to cancel each other out, which is what we want. Therefore, we know that somewhere out here-ish is going to be where the field is going to be zero. So it's got to be to the right of Q2. It can't be in between. And you could do the same thing. You could say, okay, it's coming in over here and out over here, so I'm going to say it's over here. And that's fine. So long as you keep track of your positive and negative signs, you're fine. But seeing as we're calling this the origin at zero, and going this way is positive, it's just going to make the math a little neater if we move everything that direction. Okay, so we know D. One of the things that we can do, one of the tricks to the trade, is to say we know that this distance out here is going to be, say, you could call it L, or you could call it X, or you could call it P. Just depends. I'm just going to call it X. So this distance from here to here is my 2.4 meters plus X. Sorry about that. That would be X minus 2.4 meters. And there's all sorts of different ways you can do this. You don't have to do it my way. I've seen it done where you call this distance X and this distance 2.4 and then work from there. So whatever makes most sense to you is go for it. But essentially all you need to do is define for yourself where the final distance would be. You know, if it was in here, then define it as that. And then your second point needs to be relative to wherever that point ends up being. Okay. So electric field, the total, is going to be the sum of my two fields. So E1 plus E2 equals E total. Oops. What we want for these things to be zero is for E1 to equal E2. So we know what our equations for Q are, and I've defined these distances, and I'm going to stick with them. I'm going to scoop my paper up, and I'm going to say E1 is reference to Q1, So k q1 over, and I'm saying that distance is x squared. Okay. Then the second one is k q2, and I said that distance is x minus 2.4 meters squared. For the sake of not making this a horrendous mess with the algebra, I'm going to, and I know I never do this, ignore units. You're going to see why I'm doing that in just a second. Because what I need to do is get rid of my fractions and turn this into a quadratic equation. And I'm going to do that by multiplying this up here and this over here. So I'll end up, first you'll see my k's cancel out. Cool. So I end up with q1 times x minus 2.4 squared, the square in the right place, equals q2 times x squared. So now we need to FOIL this out. And if you're a little bit rusty, I'll go ahead and show you just this once how to do that. So you're just going to piecemeal, make sure that all the pieces have been multiplied together. So they call it first pieces, outside, inside, last. That's what FOIL stands for. So x times x, x squared, minus 2.4 times x, minus 2.4 times x, plus 2.4 squared. And combine our pieces. I just did it differently than I did it when I was looking at it. 4.8x plus 5.76 is what all of this simplifies down to. So all that is from there. And we did that because we have, ooh, don't drop my subscripts. We have a q1 times all of this equals our q2 times x squared. So we're almost there. Now we need to push this into all of that, or what a lot of people do is they like to go ahead and just divide q1 by q2. So actually, let's try, ooh, big nasty bug, hold on. The bug is taking a break. Okay, what I'm going to do is then go ahead and divide this over here. So I'll rewrite x squared minus 4.8x plus 5.76 equals q2 divided by q1 times x squared. Cool. Now I want to move this over to this side, or I can move everything over here. It doesn't matter. q2, is it bigger than? So I'm going to move this over here. So x squared on the outside, 1 minus q2 over q1. Perhaps I should show you why I just did that. Let me not take shortcuts there. So you can see. There we go. So I am going to subtract this on this side, so and I want to group them. q2 over q1 times x squared minus 4.8x plus 5.76 equals 0. This is, we're getting set up for the quadratic equation. And I don't know why my eraser keeps doing that. Alright, so the step that I skipped and just kind of did in my head is I want this just to be x squared. So I can factor out the x squared from this piece here. And my x squared, and I get a 1, that's from this. Whoops. 1 minus my Q2 over Q1. There we go, minus 4.8x plus 5.76 equals 0. Now these are numbers, so I can simplify this expression and I will finally have my quadratic equation. So I'm just going to do my Q2 divided by my Q1 and we'll be set. Now the one thing I do want to remind you of is that this, just like with our forces, is the absolute value of the charges. We are not going to come down here and start worrying about who's positive and who's negative. This is still just the absolute value of each charge, just like we did with our forces. And after I've simplified it, the Q2 divided by Q1 is 0.2, so I end up with 0.8x squared minus 4.8x plus 5.76 equals 0. Now I'm ready to do my quadratic. Okay, because I was running out of room and starting to smush things, I just moved to a different page. So here's the quadratic equation. And all the quadratic equation does is it looks at a shape like this. As we get this, and the solution to this equation is where these lines intercept the x-axis. All right. So this is our A component, and this is our B, and this is our C, our constant. Cool. So all we have to do is take these pieces, the coefficients, and put them into this equation. Now the negative signs do matter. So we'll get negative B, which makes that a positive 4.8. Positive 4.8 plus or minus the square root of b squared. So we've talked about this in class before. You can leave the negative in there, but you need to remember in your calculator to do the parentheses around the negative sign. Otherwise, your calculator will give you 4.8 squared and its negative value. So just that reminder. Times 4 times a, which is the 0.8. Now we're not squaring anything, so if we have a negative that needs to be included here, times 5.76. Good. So A and C are both positive, so that subtraction stays. Divided by 2 times A. And again, A is positive, so that stays. And now we put all of that into our handy-dandy calculators. And we get x equals 4.34 and x equals 1.658. So that's just where these intercepts are. Then I'll look up what the proper word is later. Now I'm hung up on it. Okay, so now let's go back to this picture. We came up with two numbers. One is 4.34, and I want to make sure you can see, and one is the 1.658. Come over here, and this is at 2.4. We originally said that 1.658, which would be in front of this 2.4, doesn't make any sense. Those two fields are additive. It's not going to be 0 here. So that 1.658 answer is out. Come over here now, 4.34, it is indeed beyond Q2, so that number makes sense. So x equals 4.34. That tells us how far away from at Q1 it is, but to be complete, so Q1 needs to be 4.34 meters. I'm sorry, it needs to be 4.34 meters from Q1. From Q1. And Q2, remember we defined that as x minus 2.4 meters. So that one is going to be x, 4.34 meters, minus the 2.4 meters. And that one equals something. That one equals 1.94 meters. So that makes sense. So somewhere right about here. Okay, so my imaginary line I already drew in there. So that is it. We have found now where the electric field sum to zero, or will be zero with these 2 points together. The electric field, not the electric force. So we are just the KQ over R squared, just the one charge to get there. We took into account the direction of the electric fields. We did this quadratic stuff, which, I don't know, it's not so bad once you get used to it. And then we came up with that. Now I know some of you are thinking, we really have to do that in 5 minutes, and so Mom might give you like 7 or 6.5. But I have confidence in you. A little bit of practice, and you'll be doing this in 5 and under. I have confidence.